Beginning Greenbelt Week 3. In this one, we're going to discuss project tools and the metrics used to get the projects done. When you're talking about Six Sigma, you're talking about the project. And that all starts with the project charter. Whenever I do consulting, this is negotiated before you even come into the company. First off, the business case. How much money is at stake here? We're talking about money or market share. Anything that will help the business get better in this marketplace. Problem statement. What exactly do you want us to fix? And it's got to be very, very concise. You might have to negotiate that. It might be too big, not well defined, but the negotiation is a big part of this. And also, how big do you want? Are you talking about just one factory? Are you talking about across several factories? Are you talking about one cell? What is the scope? You want it to be big enough so it makes an impact, but not small enough so it doesn't make an impact, a big impact. And what is the ultimate goal? Is it reduce scrap? Is it, and make these goals, don't make them like real small goals, make them bold. Reduce scrap by 50%, reduce medicine misapplications by 70%. Make them very, very big. And when do you want this? When are the milestones? When do you deliver this project? And who's going to be on the team? You want a team of about 5 to 9 people. Don't make it too big so it doesn't work, or don't make it too small. You want that diversity in it. And resources. What resources do you need from the management? Do you need external help? Do you need a meeting room? Do you need time? Whatever resources you need to identify those and find the stakeholders, not just management or the people doing the project, but also customers, vendors, whoever ever might be have a stake in this. When looking for the Six Sigma projects, these are some of the tools you might look at. Pareto diagrams. You got a problem. Where's the problem coming from? Is it a certain customer? Is it a department? Is it a facility? What is it? You do this thing, you make this Pareto diagram. Flow chart. You look at how the product or service flows through your organization. You look at where the biggest problem is coming from. What step is causing the biggest problem? Voice of the customer. This is also called QFD or House of Quality. You basically, you just got what the customer needs and how well you're meeting those needs. Kano model. This is where you look at what it takes to satisfy a customer. There's the basic requirements or expectations. Then you got the normal. These are things that they expect, but if you don't have them, they might be a total dissatisfier. And finally, you got the wow or beyond, exceed customer expectations. These are the things customers will really remember. That's where you want to get to. Critical to quality tree. What this is, you take a measurable metrics on your product and service, and these are critical to make the customer satisfied. So what you want to do is you look at that and say, okay, I've got to improve these metrics, and the customer satisfaction will go up. And finally, the affinity diagram. So you've got a lot of ideas, you got a lot of thoughts flown out there. You got to organize this chaos. Affinity, what you do is you try to move these things into different groups, and you work on it. Try to organize it, organize a process or procedure based on a bunch of chaotic individual ideas. What is quality? This is a tough question to answer. Garvin and Besserfield did probably the best study on this. They came up with 9 dimensions of quality. Performance, features, what does it have on it? Conformance, how well does it meet the requirements? Reliability, does it work every time you need it, or is it sporadic? Durability, does it work in the environments that it's supposed to? Is it easy to service? Does it respond if you're talking about a service? Aesthetics, what does this thing look like? And also the reputation. And these things vary from customer to customer. Another thing is roll throughput yield. Most people measure their success by final first pass yield. In other words, how many make it past that, go into the final step, which is usually test or inspection, and get through that. But it's how much you lose throughout the entire process. I had one kid, he wanted to do a black belt project. It's to reduce first pass failures of a hydraulic valve. What he did is he put an air test about halfway up through the process. He caught all these leakers up there. So actually his first pass yield went up, but if you look at the road throughput yield, it actually didn't get any better. So it was like, nice try, Eric, but no, he didn't fix anything. You just moved the problem to a different source or it'd be invisible. Project planning. You spend about 95% of the time thinking about how you're going to do something and 5% actually doing it. And you want to achieve the goals and desired performance or technology within the budget or the committed resources. 3 stages: planning, scheduling, and controlling. So the planning should be about 95%, like we said. Scheduling, maybe another 2%, and then controlling while you're doing the management. Some elements of project planning. First, I identify the scheduled time limits, and there's many tools that will do this, way beyond the scope of this class. But you want to make sure you know how much time you have. You hit those limits. You want to delegate the responsibilities. Don't try to do a project all by yourself. It just won't work. And also you want to do reporting methods. How are you going to get the feedback from the people actually helping you with this project? And how are you going to get the project done? Selecting the methodologies. How are you going to do this thing? And what kind of metrics are you going to have? This should be in the planning phase. And you should actually measure your metrics as how you're doing compared to plan. And the sooner you can identify a problem, the better. Fix it before it becomes a big problem. Corrective action to problems. How do you fix that problem? And how do you know when you're done? You ever seen these teams that just keep on going on forever? We got to have an objective, and once you get that objective, okay, you're good. And you got to have midterm objectives too. Just keep hitting these milestones. And also, you want to build on projects. So once you get your objectives, you just keep on building on that, keep on getting better and better and better. We're going to talk about evolutionary operations later on. Some project planning. The most basic type is work breakdown structure. Who does what, when, and that's the way most organizations operate. More sophisticated techniques are what's called the PERT, or Program Evaluation and Review Technique. It's a systematic way of making sure doing some tasks in parallel and getting everything done. Critical path method. There are certain things you have to do in sequence to make sure you complete the task on time. Others aren't that critical, so you can let them slide back and forth. Critical path method identifies these. In Gantt charts or bar charts, there's actually I've got a link to the ASQ website. There's one in there where you can do the Gantt chart. This is also a good one. So basically, don't reinvent some kind of project planning technique if you've already got one in your organization. Use it, and use it in a Six Sigma project. Project documentation. You can do a manual, but most people do have the electronic version. And I've gone to where I just put everything in PowerPoint and use that as a final. Again, I've attached a project in the discussion part. But you want to know what is being measured, why it's being measured. Again, you're going to put some numbers to it. How much money is it saving? How much scrap is it reducing? How often is it reported? And again, this will vary from organization to organization. I usually try to get about once a week. And when to report unusual events. And I can't think of it when it's not right away. Right away is when you want to report that. And feedback. You want to have management involved in this and have them give you some input. There's nothing worse than work on a project. It's not what management wants. And you keep on using this until the project is done. You give certain milestone reporting. Every so often report. Again, we do it once a week. We have a meeting. It seems to work out pretty good for us. Risk analysis. Anytime you make a change, you're going to incur some kind of risk. And you want to plan for that. This is a risk analysis methodology. You plan for it. You do an assessment. How are you going to handle your risk? I mean, who's going to be responsible for it? And how do you monitor this risk? I'm going to attach a couple of presentations, PowerPoint presentations. One is on SPC. The other one is FEMA, Failure Mode and Equipment Analysis. And that does risk analysis pretty well. There's also a template on the ASQ.org site for FEMA. And there's another methodology I'll talk about in the next slide. This is a model for risk analysis. What you want to do is just keep on going around in circles and keep on doing each one of these. So what you want to do is you want to identify the risk, analyze that risk. How are you going to deal with that risk or plan? How are you going to track that risk is really happening? How are you controlling that risk during your process or service or making the product? And if it does happen, how are you going to mitigate it? How are you going to lessen the effects of it? And throughout this whole process, you want to communicate. That's the biggest problem in every organization, a lack of communication. And you got to have a system for communicating. Well, it's time to close the project, and what you want to do is do the final report. And again, I've attached one for an example. There's also plenty on the internet you can look up. And in that report, you want to learn your lessons, what resources you need, how effective was it, how was your tracking mechanism, did it work, was management involved, how did teamwork go, was the recognition, what was the effectiveness of those actions, did it really work, and the quality of the product or services, did it actually get better. And then you want to archive this. In other words, you don't want to put it away and never look at it again, but you want to make sure you save that, not do the same project over and over and over because it keeps on breaking every 6 months. But at the same time, you want to learn your lessons. Okay, in 1976, the Japanese Union of Scientists and Engineers came up with these 7 management and planning tools. What they did is they tried to make sure that major plans did not fail in major projects. So what they did is, I'm going to go in basically from the abstract to the most detailed. The first one is relations diagram. What this does is shows the cause and effect of relationships and analyze the links between the different aspects of a complex situation. And then we have the affinity diagram, which organizes a large number of ideas from their chaos, like we talked about, into their natural relationships. And then the systematic diagram, or tree diagram, breaks down broad categories into finer and finer levels of detail. And again, you're going from the very abstract into more and more detail. Okay. And the matrix data analysis, or the matrix diagram, I'm sorry, is a relationship between, 2, 3, 4 groups of information, and give information about the information. In other words, why are these related? What's their strengths, and how they play in various metrics? How they all fit in together? And then you got the matrix data analysis, which is complex. This is a mathematical technique for analyzing matrices, and it helps you prioritize things. It's very rigorous, careful, time-consuming, and it's a decision-making tool. It uses like an L-shaped matrix. And next we go into the process decision chart, or the and what that is, it's basically it systematically identifies what might go wrong. Say, what if this happens? How could it happen? And finally, we get into the arrow diagram, which shows the required order of tasks in order to complete the project. It schedules the entire project and how they all fit in together. Every one of these tools is probably a day or two-day class on each one of them. I'm not saying you have to use them, but they're there if you need them. And if your organization has them, definitely use them. Some of the ways to measure success: business results, process performance, defects. There's a thing called defects per unit, and basically this is the number of defects that happen on every product or service that you have. So like say you had making a car, and it comes out an average of about 7 things wrong with that car as it comes off the assembly line. That's 7 defects per unit. And then if you want to normalize that to compare different areas, what you do is you do a ratio, and you turn that DPOs into defects per million opportunities per opportunity. In other words, how many ways can you screw up a windshield for an opportunity, and how many times you get that wrong? If I get defects per million opportunities, what this is, it just basically takes that DPU and does a ratio and turns it, if you had 1 million chances at this, how many would I expect, or ppm? And a couple ways of measuring yield: throughput yield, or rolled throughput yield. Throughput yield is what they call first pass yield. It's how many go to that final stage and come off that final stage without a defect. And this way most companies measure. A better measure is the rolled throughput yield. How much you start off at the beginning of the entire process and how much you end up with. So you might start off with 100 units, lose maybe 10 at the machining, lose another 5 at the assembly. Then during this assembly or test, you might lose 2, and then at packing you might lose 1. So your first pass yield might be 2 at the test, but it's a lot more than that. It's more like 17 defects. And finally, you can convert this to sigma level. There's a relationship between parts per million, sigma level, and sigma level. My personal feel on this: if you have a current metric, you know how bad you are now, and you can measure it, and you can measure the progress of towards getting towards better, you're okay. I don't spend a lot of time doing Six Sigma metrics or inventing new metrics to measure my success. As long as I have some way of measuring if I got better or not, I'm happy. Cost of poor quality. Crosby was the first vice president of quality over a major organization, ITT, and he basically did some studies. He found if you improve your quality, it's basically free. Well, I've done further studies. They found that not only is it free, it actually pays for itself. In that example I attached in the discussion of a project, that saved the company $3.2 million. 18% of their net profit came from Six Sigma projects, and it's only about 12 people in those classes. The first cost of poor quality is prevention costs. What do you do to prevent the thing from breaking? This is probably the cheapest way to fix it. Make it so it can't go wrong. You know, you might, and if you look at this, you like in a hospital, this is where you have kits. Okay, this is my stroke kit. This is the one that came up with it. Or this is my pain kit. So you can't over-medicate. You can't miss a medication. It's there as a kit. You look at it and say, okay, yep. Or the pill bottles. You fill the bills for every day. That way you don't double take your medicine or something like that. Appraisal costs. This is where you run a test. And this is about 10 times usually more expensive than prevention costs. And this is basically where you come in and say, okay, I'm going to run a test, make sure it works okay. You want to get away from this. If you can get away from appraisal costs and put in prevention costs, you're a lot better. And you'll see this in healthcare also. Preventive healthcare is a lot cheaper than fixing the disease, curing the disease. And failure. This is where there's an internal failure where it fails right there where you're looking at it at the test stand, or there's external, the customer finds it. Again, this is probably about 10 times more than the appraisal cost. So any defect you can prevent from happening, the preventive cost usually saves you $100. $1 saved in preventive cost is spent in preventive cost, saves you about $100 in the failure cost. It just goes up that quickly, exponentially on a scale of 10. It does study and study is proven. And here are the links.